Hello students. This is a class on steps of simulation under MCS 502 modeling in simulation. This class material is already circulated through Google Classroom. I think you might have received it. So today our topic is steps of simulation. There are 6 steps in the simulation process. In the earlier classes also we have discussed simulation and steps. Now in this class we are explaining the details of simulation and its steps. Problem formulation. Problem formulation, if we see what is a problem formulation. Problem formulation is the step to identify the user attributes and needs, where 3 different components are there: problem identification, problem selection, problem definition. At the very beginning, any designer or programmer or researcher, they identify the problem, and once the problem is identified, then problem selection. That means selection of problem is again another step in the problem formulation, because in the identification process there may be number of problems. So out of that, the appropriate problem will be selected, and the next level problem will be defined. So these are the subcomponents of problem formulation: problem identification, then problem selection, then problem definition. In problem formulation, the problem is further defined through objective observations of the process to be studied. After formulating the model, the type of data to collect is determined. Problem formulation is the overall problem identification up to problem definition. In the problem definition, the problem is defined, and what are the inputs, what are the outputs, how the problem will be, what are the expected output, how, when, who will supply the inputs to the program or the simulation. Everything will be discussed in the problem definition part. So problem identification and problem selection, these are, you can say, not so deterministic approach, but problem definition, it must be deterministic. It must be a finite. It must be finite, because problem must be defined properly before starting the solution or the simulation work. Next level of simulation is data collection and analysis. As I have told you, in the problem definition part, the inputs will be defined. So once the input is very much clear, then from where the inputs will come? What are the sources of inputs? So finding out the inputs from the sources is nothing but the data collection. If we see the definition here, data collection is the process of collecting and measuring the data on targeted variables through a thoroughly established system to evaluate outcomes by answering relevant questions. Different types of sources are there, either from the books, reports, or journals. That means library is one of the major source of data collection. Nowadays, other than library, we have internet, online sources, Wikipedia, different encyclopedias, data repository. These are available nowadays. Then we have some collected repository, like one is public repository that is available in internet, and there are some restricted repositories which is there in the network on internet, but it's not available to all. It's restricted. That means you have to subscribe the services, then only you can access the data. Then purchasing data from organizations, that is also another source. There are many scientific organizations, they sell data. For example, Indian Meteorological Department, IMD, you might have heard about that, Mosam Department. Suppose you need rain data, rain information of a particular place, of a particular district of your area. Suppose you have approached IMD or Mosam Department, they will charge for a particular rain data. Suppose you need a month-long data, so suppose one data cost 5 rupees, so 5 into 30. So this way they will calculate the total price and they will give you. So that is another example. Then you might have heard about DNA sequencing and all that. Suppose you need DNA sequencing for a particular species. Then you have approached some laboratory. They will give you the DNA sequence, but they will charge for that. And many biological researchers, they do like that. Then next is collecting by surveys and questionnaires. Yes, that is also a very good source of data collection. You might have seen many people, they do some sort of surveys. Exit poll, you might have heard about that. After election, different news agencies, they conduct some survey, and on the basis of their survey, they publish the result. Just before the day of counting, exit poll, they publish the result. So these kind of surveys are nothing but another source of data collection. And in different occasions, we have seen, suppose somebody is doing PhD, so they will make some questionnaire, set of questions, and they collect, they approach to different people, different group of people, and they collect their answers. So that is questionnaires. And out of that, if they are suppose approaching 1,000 people, and 1,000 people will respond to their questionnaire, and later on they will make some conclusion out of the answers. So that is another source of data collection. So these are some of the data collecting sources. Then we have some primary data collection methods. And what are the different types of methods involved in data collection? You can see here in the first diagram, primary data collection methods. There are statistical methods to collect data. Delphi techniques are there. Focus group, interview, polls, surveys. So these are the primary collection methods. Then we have secondary data collection methods also. Internet, vision statements, mission statements, government reports, sales reports, financial reports. So these are the secondary data collection methods. So there are different types of data collection methods depending on the situation of the problem, depending on the situation of the simulation, people go for their suitable data collection methods. Model development, that is third step of simulation. Model development means developing the model. Development of a desired model is the model development. That is very simple thing. But the main challenge in the model development is the complexity. time complexity and the space complexity, budgetary estimated budget, and probable expenditures, everything. So these are actually the challenges, and the main challenge of model development is the time. That means within specified or desired time, the simulation must be completed. The model development must be completed. So that is very important aspects of model development. Once the model is developed, its specification and desired outputs are checked. So in the model development, mainly specifications are checked, whether the model which is developed, is it fulfilling all the specifications or not. If the specifications are not met properly, then the model will be reviewed again. So in the first diagram, you can see input data is there, then design and implementation. Design and implementation both are there in the model development. Design means in computer science, design means nothing but the developing algorithms, and implementation means it is nothing but the coding. So designing algorithm and coding, that is actually the model development. So in the simulation of any computer science problem needs algorithm development first, and the second is coding of the program. Coding means ultimately writing the code, execution of the code, execution successfully, not like that execution is done with some errors or bugs. It must be done without errors. It must be done successfully. It must be done to get the desired output. So there are some sub-models in the model development. So there are 5 sub-models in the model development, like conceptual model. We have discussed conceptual model in the earlier classes. Then mathematical sub-model, visualization sub-model, statistical sub-model, physical or analog sub-model. So these are the sub-models in the model development. Depending on the scenario, depending on the environment, different sub-models are used during model development. So that is the third step. Fourth step is the model verification and validation. For each and every simulation, verification and validation is an important part. Verification means whatever things are developed, it will be verified with the desired output, desired result, and it will be checked with the specifications. What are the specifications of the problem, specifications of the simulation? So if we see the definition, it's verification. Verification is the process of comparing 2 or more results to ensure its accuracy. In this process, we have to compare the model's implementation and its associated data with the developer's conceptual description and specifications. So comparing, ultimately 2 or more results will be compared together to find any discrepancy in the program or not. Even some rare cases will be checked. For example, if we were finding out the factorial of a number, so you will give some exceptional inputs like 0. You will give 0, whether result is coming or not. Factorial 0 is 1. So that type of inputs will be checked. If you were doing some division operation, so it will be checked by divided by 0. That means when your denominators will be 0, what is the results coming? What are the exceptions included in the simulation model, that will be checked. So this kind of rare inputs, rare situations will be checked and verified. So this part is verification part. So once the model is verified, the next step is validation. So validation is the process of comparing two results. In this process, we need to compare the representation of a conceptual model to the real system. If the comparison is true, then it is valid, unless it is invalid model. So validation means whether the model which is designed using the simulation steps, is it really that model which is wanted, and is it related to the real model. So this part is actually the validation part. So validation part is actually a bit complex compared to verification. Validation process needs some experts comment, many things. It will be sent to different people, and it will go certain testing process also. Different types of testings will be done on the simulation, and then only the model will be declared as a valid model. So in the picture, in the diagram, you can see from physical system to the mathematical model is nothing but the modeling, and from mathematical model to the computational model is the verification, and from the computational model to the physical system is validation. So in one part you can see mathematical model to the computational model, there is coding, and from computational model to the physical system, that is prediction. So these kind of things are there in case of model verification and validation. Next step is there are some techniques to perform verification of simulation model. What are the different techniques to verify a simulation model? Yes, there are various techniques. Some of the techniques are mentioned here. Number one, debugging. By using programming skills to write and debug the program in subprograms. Debugging is actually one of the major part of any programming. Before making any program, after writing the program, compilation will be done. There will be errors, and errors will be removed by debugging, by checking its logical aspects, by checking its semantic aspects, by checking its syntactical aspects. Cross-checking by using structured walkthrough policy in which more than one person is to read the program. It's called cross-checking. Cross-checking means suppose one programmer has written the program, another programmer will check the program and find any error. If it is, then it is cross-checking. So that is another technique for verification. Then intermediate results. Intermediate results, by tracing the intermediate results and comparing them with the observed outcomes. Many times you might have seen in the programs, suppose in the mid-level, suppose one array is there where we are storing some values. So if we print the array values, we can check whether the values are ultimately storing into the array or not. So you can just put a print statement there, and you can check the values of array. So this kind of things we can include for verification. Multiple inputs, yes, different types of inputs. I have told just in the earlier slide that rare cases, rare input cases will be given into the simulation and it will be checked. So this is multiple input, and last one is comparison, comparing the simulation results with the analytical results. So that is another techniques for verification. Then we are having some techniques to perform validation of simulation model. How to validate a simulation model? So step one is design a model with high validity. Yes, high validity model will be designed. The model must be discussed with the system experts while designing. Experts' opinion will be checked during the designing. The model must interact with the client throughout the process. Yes, client, that means the real beneficiaries who will use the simulation, they will be uh, interacted, they will be involved, so that their inputs will be incorporated in the simulation process. Next, the output must supervised by system experts. There will be system level administrators, system analysts. They will give their input. They will the output must supervise. That means what are the outputs coming out of the model? They will check it. They will verify it. They will validate it. Step number 2: test the model with assumptions data. Different assumptions will be there. So different assumptions will be fed into the simulation model as the input, and output will be recorded for validation process. So that is step number 2. Step number 3: determine representative outputs of the simulation model. Representative output, that means each and every output cannot be projected, cannot be published. So what are the outputs that can be published, that can be projected? For example, new car is designed. Its speed is a concern for advertisement, for publicity. It must be published to the general public that what is the maximum speed of the vehicle. So what they do, they run the vehicle in different road conditions, different laboratories, different places, and ultimately they record the maximum speed accordingly. So in general, whatever speed we get in the brochure of any car or leaflet of any car or in the advertisement, it's nothing but the speed which is recorded in a laboratory testing. So in on road, that speed we cannot achieve. Different road conditions will be there, different traffic conditions will be there. So that speed will be just a symbolic speed. So the representative output is that one. That means which output will be published for general people. So that will be determined in the third step. So these are the techniques for validation of simulation model. Then model experimentation, the steps, probably this is a model experimentation and optimization. Experiment is a test under controlled conditions made to either demonstrate a known truth, examine the validity of a hypothesis, or determine the efficacy of something previously untried. So, as for example, we can consider that solution of sugar and water, or we can consider the preparation of tea. Adding any quantity of sugar or milk into tea without without thinking about the taste, without thinking about the outcome, just suppose we are keeping on adding, we are adding sugar, milk, and we are preparing tea. So that tea may not be a tasteful tea, that tea may not be consumed. So that is experiment. And optimization model is something different. Optimization model is a translation of the key characteristics of the simulation problem. The model consists of three elements: the objective function, decision variables, and simulation constant. Optimization means ultimately it may be a minimizing approach, it may be a maximizing approach. Maximizing means the efficiency, for example, efficiency of any model, efficiency of any simulation, it must be maximized, whereas the time cannot be maximized. Time must be minimized. So there are various factors, parameters, depending on the situations. Sometimes it needs to be maximized, sometimes it needs to be minimized. That is one part, that is the objective. And decision variable, once one factor will be maximized, along with that other factors will also be affected. So decision variables must be identified and must be checked. Suppose the level of the sugar is increased in tea, so automatically the level of the taste will be low. If the level of the milk is increased, automatically the color of the tea will be different. It will be more white than the normal. So this way we have to identify the decision variables, and at last simulation constraint will be considered. Suppose there is a constraint, milk level cannot go beyond that level. Suppose 4 tablespoon is the limit of the milk, and 3 tablespoon is the limit of the sugar. So one cannot go beyond that level. So that is nothing but the constraint. And example of optimization is, if we are considering the same problem, so getting exact taste of tea, quantity of sugar, quantity of milk is adjusted. Otherwise, taste will not be there. So experimentation, model experimentation is a huge part of simulation, because in the experimentation, many things are experimented to check the system. Before launching the system, this kind of experimentation will be done. And optimization means ultimately before launching the model, it will inputs, outputs, everything will be optimized so that it will be launched, and it will be well accepted by the general public. Last step is the implementation of the simulation results. As I have told, after experimentation, after optimization, the last step is the simulation result. That means what are the outputs which can be projected, which can be published. So that is nothing but the simulation result. And implementation of the simulation result, that means recording all the results and making a data sheet out of the simulation. So that is the last step of the simulation. All results of a simulation are not useful. Yes, that is very important. Preparing a set of useful simulation results is the implementation of simulation results. Useful simulation result set is important for real system implementation. Yes, that is very important, because ultimately simulation is for designing or for implementing a real system, not the simulation one. So simulation is a supportive or demo of the original one. So if out of the simulation or after the simulation, if the original or the real system is developed, then only the main objective of the simulation will be fulfilled. So 100% result is always expected, but 100% result is hard to achieve. 90 to 100%, yes, it's expectation, 98 to 100% high expectation. Many times people fail to achieve this high expectation, and sometimes due to miracle there is more than 100% or beyond expectation results. So that is very rare case, but yes, if determination is there, if full dedication is there, simulation gives results which is beyond expectation. So these are your steps of simulation. Thank you for viewing this video, and hope we'll publish our next video very soon, which will be the last video of Unit 1 of MCS 502 Simulation and Modeling. Thank you very much.